According to the National Electrical Code, you can mount a service disconnect horizontally indoors. NEC Section 408.16 states that service disconnecting means shall be readily accessible to the occupant or other qualified persons. NEC Section 408.16b states that service disconnecting means shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. These code sections do not specify the orientation of the service disconnect, only that it should be readily accessible. As long as the service disconnect is mounted in a location that meets the requirements of NEC Section 408.16a, it can be mounted horizontally. Several additional considerations are important. Firstly, ensure that the enclosure is suitable for horizontal mounting, meaning that the cover can be opened and closed without interference. Secondly, provide adequate space around the service disconnect for servicing and maintenance. Thirdly, label the disconnect clearly to indicate its purpose and location. Let's delve deeper into each of these considerations. Firstly, regarding enclosure suitability, it is vital to verify that the service disconnect enclosure is designed to function correctly when mounted horizontally. Most enclosures are designed to be mounted vertically, and if mounted horizontally, there might be issues with the door or cover staying open or closed properly. Check the manufacturer's specifications to ensure that horizontal mounting is an approved installation method for that specific enclosure. If the enclosure is not explicitly approved for horizontal mounting, consider using a different enclosure that is, or reinforcing the existing enclosure to ensure that the door or cover functions correctly. Consider the weight of the components within the enclosure and whether the enclosure can support that weight when mounted horizontally. Internal components may shift or become damaged if the enclosure is not properly supported. Also, think about the potential for water or debris to enter the enclosure if it is not properly sealed. Horizontal mounting could create new pathways for moisture or contaminants to enter, which could damage the electrical components inside. Ensure that any knockouts or conduit entries are properly sealed to prevent ingress. Secondly, concerning adequate space for servicing and maintenance, NEC Section 110.26 dictates requirements for working space about electrical equipment. Sufficient working space is crucial for personnel to safely and effectively perform maintenance, repairs, and inspections on the service disconnect. This space should be clear of obstructions that could impede access to the disconnect. The depth of the working space depends on the voltage to ground of the electrical equipment and the condition of the area surrounding the equipment. Condition 1 is where there is exposed live parts on one side and no live or grounded parts on the other side of the working space, or where exposed live parts are on both sides effectively guarded by insulating material. Condition 2 is where there are exposed live parts on one side and grounded parts on the other side. Condition 3 is where there are exposed live parts on both sides of the working space, not guarded as provided in Condition 1 with an operator standing between them. For example, for equipment operating at 151 volts to 600 volts, the minimum clear working space depth is 3 feet for Condition 1, 3.5 feet for Condition 2, and 4 feet for Condition 3. The width of the working space shall be the width of the equipment or 30 inches, whichever is greater. The height of the working space shall be 6.5 feet or the height of the equipment, whichever is greater. Additionally, ensure that there is adequate lighting in the working space so that personnel can clearly see the equipment and perform their tasks safely. Proper lighting reduces the risk of accidents and errors during maintenance and repair work. Access to the working space should be readily available and unobstructed. Keep the area clear of stored materials, equipment, and other items that could impede access. Consider the layout of the surrounding area and ensure that there is sufficient space to maneuver tools and equipment around the service disconnect. If the disconnect is located in a confined space, such as a narrow hallway or closet, it may be necessary to relocate it to a more accessible location. Thirdly, regarding clear labeling, clear and accurate labeling of the service disconnect is essential for safety and quick identification. The label should clearly indicate the purpose of the disconnect, such as solar PV array 1 disconnect or main disconnect for building A. Use durable labels that are resistant to fading, chemicals, and abrasion. The label should be securely attached to the disconnect enclosure so that they do not fall off or become damaged over time. Position the labels in a location that is easily visible and accessible. The label should be placed at eye level and should not be obstructed by other equipment or objects. The label should comply with applicable standards and regulations, such as the National Electrical Code, which specifies requirements for labeling electrical equipment. In addition to the purpose of the disconnect, the label should also include other relevant information such as the voltage and current rating of the disconnect, the date of installation, and the name of the installing contractor. This information can be helpful for troubleshooting and maintenance purposes. Use different colors or fonts to differentiate between different types of disconnects or to highlight important information. For example, you could use red labels for emergency disconnects or bold font for critical warnings. Ensure that the labeling is consistent throughout the electrical system. Use the same terminology and formatting for all labels to avoid confusion. Regularly inspect the labels to ensure that they are still legible and in good condition. Replace any labels that are damaged, faded, or missing. In addition to physical labels, consider using electronic labeling systems such as QR codes or RFID tags to provide additional information about the service disconnect. These systems can be accessed using a smartphone or other mobile device and can provide detailed information about the disconnect, such as wiring diagrams, maintenance records, and safety procedures. When multiple disconnects are grouped together, as in the case of the 5 solar photovoltaic array disconnects, it is especially important to clearly label each disconnect to avoid confusion. Use a consistent labeling scheme and clearly identify each disconnect by its corresponding solar photovoltaic array. Consider using a color-coded labeling system to further differentiate between the disconnects. For example, you could use different colored labels for each solar photovoltaic array or use different color tape to mark the disconnect handles. Provide a directory or legend that identifies the location and purpose of each disconnect. The directory should be located in a prominent location near the disconnects. Ensure that the directory is up to date and accurate. In the specific case of solar photovoltaic systems, the National Electrical Code contains additional requirements for disconnects and labeling. NEC Section 690.13 requires that all solar photovoltaic systems have a readily accessible disconnect that can isolate the solar photovoltaic array from the rest of the electrical system. This disconnect must be capable of disconnecting all current-carrying conductors of the solar photovoltaic array. NEC Section 690.15 requires that the disconnect be clearly labeled to indicate its purpose and location. The label must include the words solar PV disconnect or similar wording. The disconnect must also be lockable in the open position to prevent accidental reconnection during maintenance or repair. When installing multiple solar photovoltaic arrays, each array must have its own disconnect. This allows for individual arrays to be isolated for maintenance or repair without affecting the operation of the other arrays. The disconnects must be grouped together in a readily accessible location. The disconnects must be clearly labeled to indicate which solar photovoltaic array they control. The disconnects must be lockable in the open position. The National Electrical Code also contains requirements for overcurrent protection of solar photovoltaic systems. NEC Section 690.9 requires that all solar photovoltaic circuits be protected against overcurrent. Overcurrent protection can be provided by fuses or circuit breakers. The overcurrent protection device must be sized to protect the conductors and equipment from overload and short circuit. The overcurrent protection device must be located in a readily accessible location. The overcurrent protection device must be clearly labeled to indicate its purpose and location. In summary, while the National Electrical Code does not explicitly prohibit horizontal mounting of service disconnects, it is essential to consider the enclosure suitability, working space, and labeling requirements to ensure a safe and code-compliant installation. Always consult the manufacturer's specifications and local electrical codes for specific requirements and guidance. When installing service disconnects, it is important to follow all applicable safety precautions. Wear appropriate personal protective equipment, such as safety glasses and gloves, to energize the electrical system before working on it. Verify that the electrical system is de-energized using a voltage tester. Follow lockout/tagout procedures to prevent accidental re-energization of the electrical system. If you are not qualified to install service disconnects, hire a licensed electrician. A licensed electrician has the knowledge and experience to install service disconnects safely and correctly.